Okay, so in the next section, we're going to be talking about transformations. A transformation is just something that you do to a figure to change it in one way, shape, or form. Okay, so the first three transformations we're going to be talking about are reflection, rotation, and translation. And these are all what's called a rigid transformation, meaning that when I do this transformation, it's going to maybe turn my figure or spin it around, move it somewhere else. However, it's not going to change the shape or the size of that figure. So, let's skip around these definitions a little bit. When I talk about pre-image is whatever the original figure is. So whatever I'm starting with. The image is now going to be the new figure after the transformation. Okay. All right. Now the transformation is what's going to map or move the original figure onto the new figure. And lastly, we have this word isometry, which is going to be all of these transformations we're going to talk about are isometries, meaning it does not change the shape or size. So it's not changing the figure at all, it's just moving it in some way. So we have three different types of rigid transformations. Reflection, so the way I like to think of a reflection is if I were to paint something on a piece of paper and the paint's still wet and I fold that paper in half. Okay, the crease in the paper is what's called the line of reflection, and the figure that you get when that wet paint touches the other side, that is your new image, or your image, which is your new figure that you've gotten. Okay, the wet paint that you painted with, that was your pre-image. A rotation, I like to think about if you took a textbook, you tied a string to it, and you fix that string to a certain point. As you take that textbook and swing it around, okay, the way it changes, that is rotating the figure. That's taking it and spinning it around a fixed point. And translation is the easiest one of all. Translation is just taking a figure and moving it somewhere else. Not spinning it, we're not flipping it, we're just relocating it somewhere else. Okay. Some transformation involves labels. When you name an image, take a corresponding point of the pre-image. Okay, so remember, pre-image is your original. And we're going to add a prime symbol. Okay, so when I'm looking, for instance, this black and white picture here, in order to know which one is the one I started with and which one's the one I got after doing the transformation, I have to label them differently. So my original figure is ABC in this case, or triangle ABC. The new figure I get is A prime, B prime, C prime. And that tells me that I've taken that figure, the original one, the pre-image, and I've transformed it somehow. Whether I reflected it, translated it, or rotated it, I now have this new figure, A prime, B prime, C prime. Now we're going to get into later in this chapter is what's called a composition of transformations, and that's when maybe I rotate that figure and then I reflect it and then I translate it. So what we can do, similar to when we use arc marks or congruent marks or tick marks, I should say, in some of the other stuff we've done, is that I can add a prime mark each time that I've changed this figure. So you might see something. So for instance, with this, if I now took A prime and I moved it again, I would make it a double prime. And if I moved it again, I'd make it a triple prime. So you can see more than one prime mark on a figure. So for this example, let's use a graph, name and describe the transformation. So we're going to have a couple of different ways, and it depends on what transformation we're talking about. If we're talking about a reflection, we'll get into this individually in each section. When we talk about a reflection, we're going to state that reflection is over a given line. Okay, so I reflected over the x-axis. I reflected over the y-axis. I reflected over the line x equals 2. So we're going to say that's going to be the description of the reflection, and of course the name in this case would be reflection. If we were to talk about a translation, we would say how we moved that. And there's going to be 2 different notations we use for that. But basically, we would be saying, did we go left 5 and up 2? Did we go right 7 and down 8? So that would be an example of that. And lastly, a rotation, we would describe what point we rotated the figure around. So again, if we were talking about taking that string and tying it to a fixed point, what point was that I tied that string to? In this class, all we are going to be doing is rotating around the origin. We're not going to get into rotating around any other point, but that is something that is possible to do. So for my description here, again, remembering that because this first figure has no prime marks on it, that this is my pre-image or my original figure. Okay, so if we take a picture of it, if we take a look at this and see what happens, it looks as though we took this triangle and we flipped it or reflected it over here to the other side. So this would first of all be a reflection. And again, if you think of a reflection as that wet paint, and the crease in the paper is where you reflect, is the line you reflected over. In this case, it looks like I reflected right over this line, which of course we know is the y-axis. So I would say this is a reflection over the y-axis. Name the coordinates of the vertices of the image. So again, vocabulary very important. Image is referring to this new figure. So I need to name A prime, which we can see is at 1, 2, 3, 4, 5, 1. B prime, which is at 4, 1, 2, 3, 4, 5, 4, 5. And C prime, which is at 1, 1. And the last question is triangle ABC congruent to its image? And we can say yes, because as you can see, okay, this hasn't changed the shape, it hasn't changed the size. All it's done is it's flipped it so that it's backwards and in a different location. And again, the 3 that we're going to start with, translation, rotation, or reflection, are all isometries, meaning when you do this, any of those 3 transformations, it will never change the original figure. It will always be congruent. Which of these appear to be isometry? So again, isometry is any of those 3 rigid transformations that we just discussed, meaning that neither the shape nor the size changed. Okay, so if we look from our original figure, or again, it's not labeled so we don't know which one's which, but if we compare the 2 figures, we can see that they are the same shape, they're the same size. One is just flipped backwards from the other. Okay, so this would be an isometry. If we look at our trapezoids here, we can see clearly that this trapezoid is much smaller than this. So because the size changed, we would say this is not an isometry. And if we look at our 2 triangles here, again, this is just looking as though it's been rotated around a given point. Okay, we could say that this is an isometry because although it's rotated, it's spun around, it is still the same shape and size. Mappings, we're going to talk about when I move one figure to the other, we're going to have ones that correspond. And this is no different than when we talked about congruent triangles earlier in chapter 4. So when I'm mapping points, it's just saying that one specific point corresponds to another. So for instance, in triangle ABC is mapped onto triangle DEF because A is first. Because A is first and D is first, we can say that A maps onto D. Because B is second and E is second, we can say B maps onto E. And of course, C maps onto F. In example 3, the diagram triangle PQR is mapped onto triangle XYZ. The mapping is a rotation. Given that triangle PQR maps onto triangle XYZ as an isometry, find the length of segment XY and the measure of angle Z. So again, just like what we completed recently for geometry, since XY is first and second, we're looking for the length of PQ. So if we look at our diagram, we can see that the length of PQ is 6. So that means the measure of XY would be 6. Again, remember when we talk about the measurement of a side, we do not put that notation on top. And when we talk about the measure of an angle, we put the M in front. And because Z is last, it's going to be the same measure as angle R. And if we look at the diagram, we see that angle R is 89 degrees. So basically this is just using what we just learned about congruent triangles, but saying that you need that extra information to know that because it's an isometry, these figures will in fact be congruent. So you can use all those properties that we just learned in chapter 4. Okay, and that's all we're going to talk about for this first section. The next section we'll talk about reflections.